The next speaker is Jed Buchwald, who will speak about how calculations invaded the deep past. Please.
Well, let me see if I can pull up the other presentation. It should be here. There we go. And let's see. Where do I tell it to play? So, what I'm going to talk about a little bit is to flesh out what the background to the way Newton handled data is. Now, I should confess from the beginning, in my 39 years as an academic, this is certainly the most unusual conference I've ever attended. I was trained as a physicist and became a historian subsequently, and Modi and I, some time ago, decided to work on this particular subject. I had written books on the history of optics and electrodynamics and so on. And the driving force, I think, behind the way in which Newton treated the past is entirely consistent with the way in which he treated everything from optics to mechanics, and in general, the development of an entirely novel experimental method. And I'm going to talk for a few moments about that and then show you exactly what he did. A good part of our book is actually concerned with how Newton is actually the man who instantiated an entirely new way of handling discrepant experimental data. Totally unusual for the time, not done by anybody else. This is the young Newton as he went up to Cambridge, and it was there that he developed a particular way of handling the discrepancies produced in observations and experimental structures. This is a famous diagram from one of his early manuscripts in which he pushed further than Descartes, Hooke, and others in skepticism concerning the reliability of the senses by sticking a stick underneath his eye and pushing on his eyeball in order to generate phosphenes, false colors, in order to be able to distinguish such things from the observations he was soon to make in his great discoveries of dispersion, prismatic dispersion. Now, this is about the mid-1660s, a little bit later, late 1660s. Let me jump ahead quickly to this particular manuscript. Obviously, I'm not going to show you much on it. This is the first extant manuscript. It's an actual experimental one. And I should say that one thing that may distinguish something that we work on from something that many of you do is I'm reasonably confident that Newton actually did exist. We've got his manuscripts and so on. This is the actual first use of an averaging technique in order to extract a reliable number out of a set of discrepant measurements. Nobody, and I want to emphasize that, nobody else was doing that in the 17th century until almost the end, maybe the beginning of the 18th century. There was no statistical rationale for doing such a thing at all, and the usual technique, exemplified by Huygens, Hooke, many others at the time, was to keep working until you were confident that you had produced a reliable result. You then took that reliable result, and that was the one you published. You didn't dare publish all of the numbers, because if you did, that would have been a signal to everybody that you didn't know what you were doing. You published the right one in the end. Statistical techniques only come into being in the middle of the 18th century and a little bit later. And then there were arguments over whether you should use the median or the average for various circumstances. Newton, however, does deploy the average. I can say later on a few words about how and why he justified that. This is a text from about 1700. You see Isaac up there and his archfoe Leibniz down there. This is a text in which Newton was asked to comment on Leibniz's request to the Royal Society concerning the possibility of England moving to the Gregorian dating system. England, of course, stayed on the Julian for quite a few years. I can't go into it, but what is significant about it, this is actually the first use by any scientist anywhere of a regression analysis. He attempted to take data from the past, actually Hipparchan data, as well as Thales concerning eclipses, to draw a line through the data and then regenerate accurate data by regressing the data at the time. Nobody else is doing anything like this at the time, and it's critical for understanding exactly what he did when he came to ancient history. Now, I have to move along quickly because there are a number of things I want to show you. Newton moved to London in the 1690s. He was actually an MP for Cambridge. Famous stories that in Parliament he spoke only once, and that was to ask somebody to open a window. He wasn't exactly deeply engaged. Well, although he was engaged in the politics of the era, particularly concerning the Glorious Revolution. But this is actually the house that he lived in on Jermyn Street during that period of time. I'm sure it's been gussied up since then, of course. He became first warden of the mint and then master of the mint. Now you may ask why. Well, his friend John Locke was involved in this. This involved the recoinage in England because of the problems that had arisen in exchange processes resulting from constant coin clipping. The coins didn't have little serrations around the edges at the time, and people would constantly clip pieces off of them, melt it down, and that really screwed up the exchange processes in silver and gold between especially France and England. Newton became involved in this, and in fact, one of his most significant activities was actually acting as a judge and a criminal catcher in the courts of the time. Here, for example, is one of the many manuscripts. You can see Newton's signature down here, concerning a deposition that he took from one Kate Linton. It's actually quite an amusing story that I don't have time to go into, in which he not only interrogated her, it involved a question of coin clippers and criminals, but sent out detectives, in effect, really gendarmes, to chase down and catch associates of this person and others, bring them to court, and so on. He got involved with a very famous man of the time by the name of William Challoner, a brilliant criminal and coin clipper who made the tremendous mistake of embarrassing Newton in front of Parliament at one point. The result of that was Newton had him sent to the gallows eventually. Newton was judge and executioner, in effect, at the time. Now, why am I bringing this up? It is through this series of extensive interrogations that Newton's skepticism concerning any form of oral testimony became extraordinarily acute. He'd play off one testimony against another. He'd interrogate people back and forth. He was already skeptical of what he thought of as poetical fancies from the past. Now, what's a poetical fancy? Well, first of all, that's anything mythological, which can't be immediately euhemerized. And secondly, it was anything written in the form of poetry. Newton was completely insensitive to poetry, or for that matter, music, as it turns out. And he was quite skeptical of prose as well, unless there was, he felt, a strong pedigree running all the way back. The only one that he placed complete confidence in actually was the Masoretic version of the Bible. And the result of this was that when he came to start redoing ancient history in detail, he placed tremendous skepticism on almost any of the words, which is why he was able to manipulate them in the way in which you just heard from Modi, and which I'm now going to show you in terms of data as well. But on the other hand, he's an extraordinary scientist. This man's mind is really unparalleled in many ways. It's extraordinarily working with his manuscripts and redoing his calculations to see exactly what he did. And he was able to manipulate and monkey with words by turning them into numbers. The sine qua non for Newton was to take a passage from the past and numeralize it. If you could do that, he felt, then you had some degree of possible reliability. Now, it had been done before, of course. It had been done by, a number of people. Scaliger did it. Actually, even Tycho did it. So on, but they were only using singular remarks from the past, mostly eclipses and so on. We're going to show you now that Newton used a spectrum of things. Now, of course, skepticism concerning words is not exactly unusual at the time. There's, of course, Francis Bacon, John Locke, Newton's sometime close friend, much later, George Berkeley, and Newton himself. You'll see what he says. When the Greeks wrote only in verse, there could be no chronology nor any other history that such as was mixed with poetical fancies. The main text that Newton utilized to, how should I put it, incinerate the past in a cauldron of numbers was this. This is the only text we have from Hipparchus, 2nd century BCE, astronomer, really the founder of Greek mathematical geometrical astronomy. It's a commentary on the poem by Aratus from about a century before. Well, Aratus died probably about 50 years before Hipparchus was born. This was a poem widely used by the Greeks, especially by the Romans, to educate their young aristocrats in such things as what's up in the heavens, how it's associated with deities, and so on. But the interesting thing about it is that it contains remarks about certain things on a putative original stellar globe. That globe could not have been the globe that was described by Eudoxus, who's the one who's quoted in the Aretaean text, because of the distribution on it of constellations. It had to come from some time long before. Now, Hipparchus was skeptical of a lot of these things, but he wrote extensively and provided a lot of data which Newton was about to turn into numbers. And I will show you some of it now, especially the main ones. Here's a major passage, and I'll just read what's in red. Chiron delineated the asterisms, for Chiron was a practical astronomer. And one of the Argonauts, says Newton, made a sphere. And the sphere itself shows that it was delineated in the time of the Argonautic expedition. Now, of course, this is Chiron, but Newton had some reasons for arguing that he was an astronomer. I don't have time to go into that right now, and I'm going to show you a criticism of it later on anyway. Now, how are you going to take this data about, or these remarks about what was on this putative stellar sphere from long before Eudoxus and turn it into numbers? Well, you do that by using the phenomenon of the precession of the equinoxes. I'm sure you all know what that is, but just to tell you in case. So here's the Earth, and of course the Earth spins on its axis, but as a result of the differential effects of the sun and the moon, as well as tidal actions, the Earth spins a little bit like a top. And that rotational or conical motion has a period of about 25,920 years. That's about 1 degree every 72 years. Hipparchus, by the way, was the first to discover this. He thought it was about 1 degree every 100 years, which had a rather large effect on Hipparchus's dating of Greek chronology, by the way. In any case, because of this motion, the positions of the solstices and the equinoxes move around the zodiac over time. Now, the zodiac is the plane in which, if you just look in the sky over time, the sun seems to move during the course of the year, and more or less the planets move there as well. It was Hipparchus who introduced the 30-degree divisions of the zodiac, or fixed them rather. We know that because the zodiacal division is first called Aries, and Aries comes into position around the time of Hipparchus for the vernal equinox. Now, using that and taking the data from the commentary on Aratus, it was possible to redate the past. And now I'm going to show you how. So here's just a delineation of the plane of the zodiac, the ecliptic. Here's the equator. Here's a horizon. And stars will rise and set as the globe of the stars seems to move around. And the sun's position on the zodiac will change over time during the course of the year. And there are two particular great circles of this device that are referred to by Hipparchus. These are called the colliers. The colliers are the colliers of the solstices and the equinoxes. They're great circles which intersect the equator and the ecliptic. And when the sun sits at these intersections, you either have an equinox or you have a solstice. Now, over time, the summer solstice, well, as well as the winter solstice, moves through the constellations. So you can see here in about 5000 BCE, the summer solstice was in Virgo. As you move down into Pharaonic times, it moves through into Leo, Cancer, and Gemini till around United Monarchy times, and so on and, until you get to Newton's time a little bit later. Hipparchus makes many remarks about these colliers. Here's one. Hipparchus tells us, says Newton, that's a text from Newton, that Eudoxus, again, it can't be Eudoxus, this is what Hipparchus is saying, drew the collier of the solstices through the middle of the Great Bear. Now, what Newton is going to do is take remarks like that and try and turn them into numbers. Now, how are you going to do that? All right, so this is a Great Bear. Leo, Cancer, Gemini, from a modern projection that I use. But how do we know what these things looked like in antiquity? Well, we have the Farnese globe, which is a Roman reproduction and probably, though not certainly, represents a design that dates to the time of Hipparchus, but you can see what the delineations look like there on that thing. But more to the point, the delineations of the constellation representations are culturally completely dependent. Here's one from the famous Leiden Aratea of the 9th century of Gemini, and you see the little yellow dots marked stars. Here's an even later manuscripts, 12th century, showing Cancer and Leo, also at Leiden. Here's a Persian one from the early 17th century. Gemini also has dots on it to mark stars in, you'll note, rather different positions in respect to the delineation from the previous one. Closer to Newton's time, one by famous artist Schiller depicting St. James as Gemini. Here's the one Newton used from the Bayer Atlas, the early 17th century, Gemini. But if we go later to Newton's contemporary Flamsteed, the first royal astronomer, you see a rather different depiction. And in all of these, the stars are in different positions in respect to the delineations. And what you have in antiquity is some remarks from Ptolemy in the Almagest concerning what stars are where in these delineations, but he doesn't draw these things. Now, in order to do anything with these remarks and turn them into numbers, you need coordinates. Newton had coordinates from Tycho Brahe, around 1600. They were the most accurate ones available at the time. They had to be updated because of precession for his use. He had them available in this, the Astronomia Britannica, as well as a number of other places at the time that he could draw on in order to do his calculations. But by 1690, he had the highly accurate observations of this man, Johannes Hevelius, a brewer from Danzig, sort of on the periphery of European science at the time, but he produced quite accurate results. And later on, Newton also had available Flamsteed's coordinates, which he didn't need. Now, Newton had a particular way of taking notes and writing things down, which is why we are able to reconstruct a lot of what he did. There are hundreds, if not thousands, of pages of manuscripts available. We even have some of the books he had. Here's Newton's copy of John Marsham. Those dog earrings are Newton's. This is in the Linda Hall Library in Kansas City. And this actually marks a page concerning Sesostris in John Marsham. And so we know exactly what he was reading. However, making sense out of his manuscripts is not easy because they all look like this. And numbers are scattered on them, remarks are here and there. He'd use one side of a piece of paper later, and so on. We know this can't be before 1706 because it's got an invitation on it and so on. But it's very difficult. And he'd copy and recopy things. The way Newton's memory worked is he would write something and then rewrite it and rewrite it and rewrite it, sometimes a dozen or more times. And in the hundreds of, well, actually several thousands of pages of manuscripts, we had to go through and collate all of that. Now, here is one little extract, so I'm just going to quickly show you how it goes, of a series of numbers. He doesn't say anything about that. And by the way, the published chronology doesn't tell you anything, because he doesn't want you to know exactly what he did, as a matter of fact. It's buried in the manuscripts. So what we did was, I would take those numbers and try and figure out what they meant so that we could reconstruct the set of data that he was actually working with. And we can do that. So these actually are logarithms up here. And these correspond, in fact, to a computation for a precessional calculation of the vernal equinox involving spherical astronomy. This actually is a calculation based on this formula over here and a table of logarithms. I even know which table of logarithms that he used because of the precise accuracy of the numbers and so on. So that's what he did. And he did this for many, many numbers. I'm going to show you the results in a moment. Now, what is critical about this, and which then relates to what I started off by saying, was that he winds up with two sets of numbers, 5 in each case, one for dates of solstices and one for dates of equinoxes. And he takes the average of each of those sets separately. Now, that just shows you his brilliance, because solstitial observations are inherently vastly less accurate than equinoctial ones. So he keeps them separate, knowing they're separate numbers, but figures that taking the average of just the solstices one will ameliorate the inherent errancy of the numerical structure itself. And then he takes a cut between the two. This is the primary result which allows him to provide a precise redating of the past. Now, I'm going to run out of time in a minute, so let me show you something. When I want to make a claim about what somebody thought, I need data and evidence for it. And so I wanted to argue that, in fact, Newton's star choices, and I don't have time to tell you exactly how he made them, were, in fact, hardly demanded by the evidence. Now, how am I going to do that? I could just say so, but in fact, I had a control. There's an astronomer by the name of Bradley Schaefer, whom I know at LSU, who didn't know that Newton had done this. And he did it himself. So he did exactly the same thing Newton did. He took the commentary on Aratus and attempted to assign numbers to the Collier remarks. And here are the results. There is not a single star, except one, which the two of them decide is the ones that ought to be used in setting up this result. They chose completely different stars. In point of fact, Schaefer somehow came to the conclusion that the stellar globe in question was designed, drawn, and discussed somewhere in Nineveh, hundreds of years before where Newton thought it was. But the point is, it's not driven, in other words, by data. Now, it doesn't mean it's irrational. Newton had very specific reasons, as does Schaefer, for making the choices that he did, especially when he coordinated it with what he thought of as textual data and so on. But nevertheless, as you can see, it's not, in the end, despite the fact that it's deeply mathematical, involves a lot of computation, and he rarely makes a mistake. I mean, in the hundreds of computations we redid, thank you, I rarely found a mistake, but it's arbitrary. Now let me show you just how arbitrary. Here's a remark, and this is one of the critical pieces of data that Newton uses. This remark, he says, Hesiod tells us that 60 days after the winter solstice, the star Arcturus rose just at sunset, and it follows, he says, that Hesiod flourished about 100 years after the death of Solomon, or in the generation or age next after the Trojan War, says Newton, as Hesiod himself declares. Now, this is a remark concerning the much debated achronical rise of Arcturus in Hesiod's works and days. You cannot calculate accurately with that. And the reason you can't is the only way you could calculate accurately is if the Earth were a perfectly smooth sphere and had no atmosphere around it. As soon as there's atmosphere, temperature gradients, and dust in the air, refraction badly affects what's known as the arcus visionis, which is when you see the sun after it sets and stars before they rise. However, if you ignore all that, which Newton did, he wasn't actually a very good astronomer that way, then you can deploy a technique described in John Battista Riccioli's Almagestum Nomen concerning the computation of the arcus of the achronical rise. And if you do that, as I said, Newton says that Hesiod tells us that 60 days after the winter solstice, the star Arcturus rose just at sunset. Now, he has an elaborate computational method. He goes through the whole thing, and let me now show you what he comes up with here. This is his quote from Hesiod. This is what he says, Hesiod says. Hesiod has told us himself that he lived in the age next after the wars of Thebes and Troy, and that this age should end when the men then living grew hoary and dropped into the grave. Is that what Hesiod said? No. This is what Hesiod said. Zeus will destroy the race of mortal men when they come to have gray hair on the temples at their birth. But Newton will not allow anything that is outside what he thinks of as the course of nature. Miracles, except a few, are out, and especially anything that dates from the pagan past, any remarks from the pagan past. So this is not a typical example of things. I don't have time to go into his estimation of the regnal lengths of Israel and Judah, except to remark that this is from the manuscript. This is actually the published result. These two things do not cohere with one another, and I spent a lot of time trying to figure out how he manipulated that to get that, and I cannot come up with an answer. But strangely enough, nobody challenged him on this. It's a regnal length calculation involving an average and so on, and there was an argument subsequently about regnal lengths. You've seen this picture of the tomb. I might remark that the collier in question is on that tomb. So it had quite an effect at the time. And I'm afraid I'll have to pretty much stop now, except to tell you that it was inscribed on globes at the time, as you can see. He was challenged by Jean Ardouin, a Jesuit at the Inscription et Belles Lettres. Very good man, except for one thing. He actually thought that all of ancient history mostly was invented by a drunk Benedictine 400 years before. And I'll stop with that. Thank you.
Thank you very much, Jed. I neglected to mention before that Jed comes from also from the California Institute of Technology. And, well, questions?
I've got a short one. That was a fascinating lecture, and I know you wanted to pack so much into it. What about the Exodus?
He really doesn't say much about the Exodus, you know, and I think there's a clear reason for that. You can't turn it into numbers. If you can't turn it into numbers, he's at sea, except with the textual concordances that Modi was telling you that he worked extensively with, and he manipulated those in ways which are not so different from his manipulation of numbers. I mean, I should say that this is not irrational what he's doing. You know, if you understand that actually the performance of experiments, the extraction of reliable knowledge from artificial situations, and what you do with those results, even in the experimental world, is pretty novel in the 17th century itself. And he's trying to extend that into a world where it doesn't really fit. And he's not the only one, by the way, who subsequently would do that. Plenty of people around today. There's a mathematician in Russia named Anatoly Fomenko who does it all the time. He's a well-known mathematician, and he also thinks all of ancient history was created about 400 years ago, in his case by some other cabal. I won't say what.
Yes, Gary.
Thank you. That was absolutely fascinating. I concur exactly with what Tom just said. This is not a question, just a comment for public service announcement. I thanked our colleagues in Chicago for putting up the pyramid text and coffin text on the internet. I go to the Cambridge University Library website almost on a daily basis to consult Hebrew manuscripts from the Cairo Geniza. But everything that we have just seen is now, correct me if I'm wrong, is now available at the CUL website. And I always start by going to look at a Newton manuscript at random, which I cannot understand in the least, but boy, is it fun.
Yes, that's true. And not only that, but one of our colleagues who's in England, he's with us right now, has been working on a very elaborate website which will be putting up diplomatic and original transcriptions of all of the Newton manuscripts. And we have, somewhat to his despair on occasion, made a lot of use of that in the last number of years.
We have time for one more question, please.
Gordon Franz, what correlation is there between Newton and James Ussher and the Ussher chronology? Any correlation at all?
Well, sure. As Modi said, he more or less subscribes to that. That is, the origin of creation and so on. He differs, considerably on what Modi mentioned. We didn't go into detail on what happens after the deluge. What got him into this originally was the problem of the expansion of populations after the deluge, because he could not credit miracles, extraordinary lengths of lives, or anything like that. So he had to try and figure out how populations expanded. By the way, he's not the only one doing that at the time. This is the origin of the period of the origin of population statistics at this precise time.